My name is Jose Gomez, and today I will be talking about constructing the potential energy diagram for the formation of a covalent bond. Covalent bonds are a chemical bond that involves the sharing of electron pairs between atoms. These electrons are known as bonding pairs. The sharing of electrons allows each atom to attain the equivalent of a full outer shell, meaning there is a more stable electronic configuration. In organic chemistry, covalent bonds are much more common than ionic bonds. Potential energy diagram shows the change in potential energy of a system as reactants are converted into products. Activation energy, the least amount of energy a reactant needs to undergo a reaction. Reverse activation energy, the least amount of energy a product needs to undergo a reverse reaction. Activated complex, an intermediate state that is formed during the conversion of reactants into products. Higher activation energy results in a more difficult reaction, and a lower activation energy results in an easier reaction. This is an example of a potential energy diagram. Line segment A shows the potential energy of reactants. Line segment D shows the potential energy of the products. Line segment C shows the activated complex, and line segment B shows the activation energy. Enthalpy change is written as delta H. It is the amount of heat evolved or absorbed in a reaction carried out at constant pressure. A catalyst is a substance that aids in the rate of a reaction process. Enthalpy change is approximately equal to the difference between the energy used to break bonds in a chemical reaction and the energy gained by the formation of a new chemical bond in the reaction. This image shows the difference between an endothermic and exothermic potential energy diagram. If reactants have a higher potential energy than products, the overall reaction releases energy. Hence, it is an exothermic reaction. If products have a higher potential energy than reactants, the overall reaction absorbs energy. Hence, it is an endothermic reaction. And now for the potential energy diagram for the formation of a covalent bond. As atoms approach one another, the electrons concentrate between the nuclei, creating an attractive force, decreasing potential energy. At short distances, the electrons of the atoms experience a repulsive force. The curve rises as R decreases. At R sub 0, the energy between the atoms is the lowest. This is point of greatest stability for the molecule, hence R sub 0, known as the equilibrium spacing of atoms. Electrostatic force at equilibrium separation is 0. This is a list of the resources that I used to research this topic, and some sites I borrowed the images from. I appreciate your time, and thank you for watching.